Okay, so we are leaving off from the Darwin 22 chapter. Yes, this should be some kind of recollection. There should be some nodding like this. Oh, Darwin. There it is. That's what I'm looking for. Yes. They should be on Desire to Learn. I'll reload them all because 22 might not have been on there because we were going to cover it later. So I'll add 22 and this study guide just to revisit, starting with homology because I went through these kind of fast. A common ancestor, and then we went to homologous structures. One of the confusing things here that I run into with homologous structures is that you get to have a personal religious belief about homologous structures. You get to have a personal religious belief about whether homologous structures point to evolution. You don't get to have a personal religious belief about whether homologous structures exist. Does that make sense? I'm not trying to crush you. I'm just saying that homologous structures exist. You may not believe they point to evolution, but they still exist. So you can't just, I don't want to learn them because I don't believe in evolution. It's fine to not believe in evolution, but you still have to believe in homologous structures. Because as you can see, all these things exist. There's not a unicorn, or the Loch Ness Monster is not up here. Humans exist, and their carpals and radius look similar to the cat's paw. From the slide, you can see how they look the same. Whales exist. And again, how the humerus and the radius and the metacarpals and the carpals all look similar, and the wings of bats. This may or may not point to evolution for you, but it still exists as something you have to know in terms of anatomy and physiology and things like that. So homologous structures are these types of things. Homologous structures are also, again, to keep you from getting this wrong because it's in the book, the male and female reproductive system, homologous structures, not vestibule. Do you see how that's just going to make me put your paper outside my door? And others will mock you? Don't do that. Comparative embryology. Again, these things are used for evolutionary evidence. You don't have to believe in evolution, but you do have to believe in like embryology. You were once an embryo. That's true. Other embryos, they kind of all look like similar blobs. And so there's the comparative anatomy. Vestigial structures, remnants of features that perhaps served a function at one time. You have the evolutionary trees. So here again you have a branch point of which you have fish and amphibians and mammals, ostriches, crocodiles, and how there's probably one main and then they moved around. Okay, convergent evolution. Did we get to this? No. No, okay. Yes, the nodding. That's what I'm looking for, yes. It's hard to see you from the smoke. Convergent evolution. This is super cool. I'm a huge fan of convergent evolution. This is mostly the work of Simon Conway Morris and some others. He's just the person that I know best. Basically what he's saying is, in a nutshell, if you were to start the world over, would it randomly, is it so random that it would look completely different than it does now? Simon Conway Morris would actually say no. It would look almost exactly the same as it does now. This is not a God of the gaps kind of thing where, oh, we can't explain convergent evolution, so there must be God. Although you can imagine that it's used for that. His best example, and what I feel like is the coolest example, is the eye. So what you have is called a camera eye. And the camera eye has evolved separately in 8 different species in a different way. So in 8 different types of species, they have evolved into something that has a very similar eye to you, what's called a camera eye. That's cool. That's like 8 different times, randomly, things have converged to where 8 different species have the exact same camera eye evolved in a different way. That's amazing. that points to, not to be a God of the gaps kind of argument, it points to there was a plan, there was a blueprint, there was a creator, there was something that had the idea in the beginning. You know what's awesome? Seeing stuff. You know what's not as awesome? Blindness. You know what makes you cool? Seeing stuff. Not only does it help you survive, right? Chicks dig boys that can see. And it's true, boys dig girls who can see them. So this makes you both able to survive and able to pass on offspring. And you can see the offspring. So cool in every aquatic, all kinds of things. This has evolved independently 8 different times. Very, very cool stuff. This is convergence. The book talks about it a lot because it wants you to see how these things happen. And one of the things that I think is missed if you never talked about evolution in your high school, or you call it the E word and no one ever brought it up to you, you miss the cool stuff like convergence. This is cool. This is really happening and it's amazing, and you miss out on it if you skip all those textbook chapters because it's the E word. You miss out on stuff like convergence, which is awesome. So again, you have these analogous traits which arise and groups independently adapt similar things like the ability to walk, the ability to speak. Even though we have a more complex language, other animals communicate in some kind of way. I'm throwing things. It's so cool, I'm just throwing things. So that's convergent evolution. It doesn't really provide necessarily a lot of family tree kinds of things, but it does provide some things. Here's some examples. Flying squirrels and sugar gliders, and both of them sort of adapted the ability to fly in some kind of a manner. If you've ever seen a flying squirrel, it's just as cool as convergent evolution. It's like, oh my, it's flying. Because you're prepared for the jumping, right? Because it's a squirrel and they're kind of But then it's like, woo. It's really, really cool. So that's an example of convergence. Okay. I do not know where analogous structures are. Fossil records. So analogous are features and similar features. So analogous structures would be the ability to see, the ability to walk. Analogous traits arise when groups independently adapt to a similar environment. Okay, moving on to Pangea. So Pangea is the idea that the Earth's continents were one big continent. We were one big giant continent, and then we broke apart into the continents we have now. This is cool. I think Pangea explains a lot. Because if you try and live in a world where there's not a Pangea, so this is one of the things that strikes my students when they go to the Creation Museum in Kentucky. I take the Core 302 group to the Creation Museum. So if you believe in a young Earth, so let's all say we all believe in a young Earth. So Earth started 6,000 years ago. God created everything in the Garden of Eden at once, right? How did it get across the ocean? If it all happened 10,000 years ago, let's say, penguins, for example, in the Garden of Eden, somehow they made it to the North Pole, or they made it to America. How does that happen if there's no Pangea? So Pangea is the idea that all evolution happened. It was all one continent. Everything spread out slowly over time. The continents separated, and you have sort of microsystems. You have different organisms that live in different places. Like we don't have kangaroos. So how did that happen? The Creation Museum story is what usually gets my students every time. During the flood, some of the animals clung to little branches and swam their way to North America. And they have a little diorama of this. Like little deer clinging to pieces of wood and making it all the way from what would have been Noah's time to like Antarctica, because you could do that on a raft. So that usually puts my students are like, really? No one ever thinks about Pangea as being true or false. It does tend to be one of those hot button issues, because if the Earth is only 10,000 years old, there wouldn't have really been a Pangea. The continents would have been the way they are now. But if the Earth is older, there would have been a Pangea, all one. Do I have I don't have a good picture of that. One, you can imagine, and then we kind of broke apart into the continents that we have now. That facilitating several things. One, evolution. So that's why you have different animals that evolve differently in, say, Antarctica than Australia, than different areas, because they found their niche, right? They took that niche and they sort of evolved to better fit into their own niche. So Pangea is somewhat of an important idea. Again, you don't have to believe in Pangea, but it's best thought out in terms of, okay, I think the Earth is really young. I believe everything was created exactly as it is now. I mean, you've got to know the Labradoodle.